Hi friends and my dear students. Today, 12th Physics 8.4.3 Atomic and Nuclear Masses. Atomic masses and nuclear masses. This is very important to know. Then only you have to understand the binding energy and mass defect and everything. Then band bridge spectrometer to identify the mass of an atom. That's why you have to keenly observe all those things what I am going to teach today. Yes, now when you think in nucleus, when you consider an atom, if you want to find out the masses of this nucleus, then it is very tiny. It is very tiny, 10 power minus 25 kg. 10 power minus 25 kg. So that it is very difficult to measure this kind of calculation in kilogram. That's why we are considering a general mass, atomic mass unit, atomic mass unit. We are considering this is the basic two for all atoms are said to be in U. Atomic mass unit. We are need not bother about in kilogram. We have to calculate all the masses, either nucleus masses or atom masses in the atomic mass unit of U. That's why we must know what is the value of U. So, what is the value of U? U is nothing but when you consider an atom carbon 6C12, then U is nothing but 12th of 1 by 12th. The value of mass of the carbon atom is equivalent to 1 by 12th of carbon atom. Carbon atom that is equal to 1 U. This is the basic equation. This is the basic equation. So 1 by 12th of carbon atom is equal to 1 atomic mass unit. Atomic mass unit. For example, 1 U equal 1 U equal carbon mass. Carbon or 6C12. 6C12 mass of carbon. Mass of carbon divided by 12. This is nothing but 1.926 into 10 power minus 26 divided by 12, and this is equal to 1.660 into 10 power minus 27 kg. One atomic mass unit is equal to 1.660 into 10 power minus 27 kilogram. This is the basic unit that we are adapted here to measure the nucleus of mass of the nucleus as well as the mass of an atom. This is a basic information that you need to understand that calculate the mass of an atom or mass of the nucleus. That's a very important concept. Then the next thing we are going to explain why we are considering carbon atom. Suppose if you are explain the masses of proton and the masses of neutron in atomic mass unit, then we can write the value of mass of neutron. Mass of neutron is nothing but 1.008665 atomic mass unit, and mass of proton is nothing but 1.007825 atomic mass unit. Similarly, if you want to find out mass of hydrogen, it is nothing but this is called 7276 mass of proton. Mass of hydrogen, that is equal to 1.00787825 atomic mass unit. This is the basic concept. Here, the mass of neutron and the mass of proton separately, you have to calculate or weighing the mass of neutron. Then one mass of neutron is called or said to be the value atomic mass unit. And mass of proton like this. And mass of hydrogen, you add these two things, then we have to calculate the mass of hydrogen. Hydrogen is nothing but one proton, plus one electron, one proton plus, that is 0 neutron. That is 0 neutron. Then how can we obtain the difference of this energy level? Why it may be differed? Here there is no neutron. When we say hydrogen atom, there is no difference of value. But when you are adding here, we can explain from here itself the binding energy. But you have to wait for some time. With a suitable example, I want to explain why the mass is differed. When you say 1H1 hydrogen atom, there is only one proton. The mass of the proton is equal to mass of the whole atom or minus mass of electron. That's why. Anyway, this here mass of hydrogen is far high when compare the mass of proton. The energy difference is due to only because of the mass defect that we are going to explain later. Now, when we generally say mass means it is denoted to the atomic masses, atomic masses, and not nuclear masses, If you say general, mass means atomic mass. It is not mentioning nuclear masses itself. You have to understand. Okay. Then what are the instruments that we are utilizing to find the value of atomic mass? Bain-Bridge spectrometer. Bain-Bridge spectrometer. This is the instrument that we are utilizing to calculate the atomic masses. Later we have to discuss about this value. Now we are going to see what is the value of total masses of we are already calculated mass of proton, mass of neutron, mass of electron, and mass of hydrogen. When you are calculating the total mass of hydrogen, suppose for example, for assuming carbon, for example, you have to consider carbon, there may be some value. And adding of these two, and this is called some value minus of Me, that is not equal to this value, because if I totally calculated the mass of hydrogen, that is equal to this value. If you are separately calculate the mass of proton, mass of neutron, mass of electron, then adding up these two is called nucleus, and then you have to separate the mass of electron only because of negative value. Then this is given value is this one is less and this one is higher. That is the difference of mass defect that we are going to explain now. What is mass defect? So before that we are going to see what is meant by nuclear size and density. Nuclear nucleus size and density. Nucleus size is nothing but when you think about Z is greater than 10, Z is greater than 10, that is atomic number is greater than 10, then R is the radius of the nucleus, then it may give R is given a value of the radius of an R is a radius, then you have to calculate the here A is the mass of the nucleus and the constant R naught, the constant R naught into A power 1 by 3. The constant value is equal to 1.2 Fermi, and here A is nothing but atomic mass number. Atomic mass number. This is the relation between R, that is the radius. This represents the size of the nucleus, size of an atom. That's why if you want to find out the radius, measurement of using different methods have been carried on the nuclei of various atoms. You have to consider the nucleus size of various atoms. You can utilize this formula, R that is equal to R naught into A power 1 by 3. Now this R represents the radius of nucleus, not radius of an atom. R is a constant value, that is 1.2 Fermi or 1.2 into 10 power minus 15 meter. This is the value. These are things that is called nucleus size. When we are going to read about the nuclear density, what is the nuclear density? Nuclear density is nothing but mass of the nuclei. Mass of the nuclei divided by mass of the nuclei divided by volume of the nuclei. Volume of the nuclei. Okay. Suppose you have to consider an atom. Here there may be n particle, proton, either proton or neutron, whatever it may be, and mass of one particle are said to be m. Therefore, a particle is available here, then a into m. This is called mass of the nuclei. Volume is nothing but 4 by 3 pi R naught cube into a. Here mass of one particle are said to be like that. There may be a particle. That's why atomic mass of the nuclei, volume of the nuclei is multiplied by A. Both are cancelled to each other, so that we get m by 4 by 3 pi R naught cubed. Here the letters are representing the nuclear density is called rho. You have to pronounce like rho. This is called rho, like this. This is a nuclear density is represented by rho. Rho is not dependent on A. That's why when you say Z is greater than 10, the rho is constant for all atoms. This is constant when Z is greater than 10. Then the density of the nuclear density is a constant for all atoms. There is no change in the nuclear density. That is a very, very important concept that you must be clear. Now, substituting the value of known values here, then rho is equal to 1.67 into 10 power minus 27 divided by 4 by 3, 4 by 3, 4 by 3 pi r naught cubed. R naught value I already told, R naught is nothing but constant, and that is equal to 1.2 into 10 power minus 15 meter. So substitute this value, we get 1.2 into 10 power minus 15 into whole cube. On solving this, we get 2.3 10 power 17 kilogram meter power minus 3 meter power minus 3. This shows that the value shows that the nucleus within the nucleus there may be a large number of particles available in the denser is more, the density is high density. That's why all nucleons are packed together in congestive manner, or in tightly nucleons are bounded inside the nucleus. That's it represents the value of 2.3 and 10 power 17. This is very, very, very close. Each and every particle are very close to each other. That is the most important concept. Next important concept. Without knowing this, you couldn't be able to answer for 3-mark question or 5-mark question or anything else in your annual examination. That's why you must keenly understand this binding energy, mass defect and binding energy. What is meant by mass defect? What is meant by mass defect? I already told when you explain the mass of proton, mass of neutron, mass of electron and mass of hydrogen. From there itself we have to explain, but it is not very easy. That's why I have to consider another very good example to explain the mass defect. Mass defect and binding energy. Binding energy. BE. This is called delta M. It may represent it as binding energy is nothing but BE, and delta M is nothing but mass defect. Suppose you have to consider 6C12 carbon atom. You are totally calculated this atomic mass or total mass of this carbon atom, that's equal to 12 atomic mass unit. Okay, are you clear? If you are calculating mass of proton and mass of neutron, that is equal how much mass of proton? 6 mass of proton, therefore 6 into MP. How many neutrons? 6, 12 minus 6, 6 mass of neutron. And you have to calculate these two, then the total value of this one is nothing but MP 6 into 1.00866 atomic mass unit, and 6 into 1.00726 atomic mass unit. 727 atomic mass unit. Now, there are 6 electrons. If there is 6 proton, there must be 6 electron. Then mass of 6 electron is equal, mass of 1 electron that's equal 0.0005 atomic mass unit. multiplied by 6, then we get total value of Z 6 MP and 6 MN and 6 ME. That is equivalent to 12 6.05196 atomic mass unit. This is called atomic mass unit. Likewise, if you calculate the total value of 6 mass of neutron, that is equal to 6.04362 6.04362 atomic mass unit. In the same manner, if you multiply the 6 into 1 mass of electron, that is equal to 0.0333 unit, atomic mass unit. Now, here, if you are calculating the total atom mass of carbon 6C12, here 6 proton, 6 neutron. If you are adding totally calculated, you get only mass that is equal to 12 U. But if you are adding these two alone, you get 12.09 8 15 5 9558. Here the total mass actually calculated, that is equal to 12. Here is, if you are calculating the mass of the proton and the mass of the neutron, adding these two, it is greater than this actual value of 12. So how much is differed? Delta M is difference of 0.09558. This is the mass defect. Less than the mass, when you are calculating this constituent particle masses and adding both of these two, we get higher value than the total mass of the atom. This mass defect are essential to bind these proton and neutron together. That's why you have to spend enormous energy to bind this proton and neutron together in the nucleus, and this amount of mass are spent for binding this proton and neutron inside the nucleus, and this energy is called binding energy. Because as per Einstein, E equal to mc square. Here binding energy, if you are saying binding energy, it is nothing but delta m c square. Delta m is nothing but, here you have to calculate Z mp plus n mn, Z mass of proton, n mass of neutron minus total mass into c square. This is called the binding energy. This is called binding energy equation. Suppose if you are adding the mass of electron, then we can modify this equation. Zmp plus n m n minus m minus z m e into c square, or you can say z mn. Here you are not adding, here you have to add z m e minus m, and then you have to minus z m e into c square. Now you have to combine together. It is nothing but z is taking outside, then mass of proton plus mass of electron plus n mass of neutron, and the minus is constant m plus z m e into c square. Z m e c square. Now this is nothing but mass of hydrogen. Mass of hydrogen. That's why we can write m z m h, that is mass of the nucleus of the hydrogen atom. Mass constituent particle of the hydrogen atom nucleus. That's why if we are adding these two, it is nothing but the nucleus of the hydrogen atom. So that I can replace this value as mass of hydrogen plus n mass of neutron minus of mass plus z m e into c square. This is the final equation for explaining the binding energy of any mass defect or binding energy. This amount of energy that needed to combine or binding together as a nucleus of proton and neutron. That's why this energy is said to be binding energy. If you want to break down this nucleus, suppose consider hydrogen atom. This is called nucleus. This is called electron. If you want to break this nucleus, then you have to spend this binding energy. This binding energy apply here, and it may be nucleus may be splitted. Nucleus may be splitted. That's why this is called binding energy. This is called binding energy. Very, very important question, and you have to understand this concept clearly. Then easy to understand. At the same time, it is very important question also. Next, on the basis of this equation, now I can modify this equation Z mh plus nmn. These are all called total mass or plus ZME. This is nothing but mass of atomic mass. Therefore, we can write binding energy is equal to ZMH plus N Mn and minus M into A. This is the final equation. We are explaining the binding energy of any atom. Binding energy of any atom. Very, very important equations. You have to thoroughly understand this concept. This may be asked in 5 mark question. Thank you, my friends. No time much.